India has made remarkable progress in recent years towards indigenous technology and self-reliance. Scientists have made significant contributions to Indian technology through the Council of Scientific and Industrial Research Organization (CSIR). The Advanced Material and Process Research Institute (AMPRI) was established by the CSIR in 2007 to provide more visibility for focused research. India is committed to sustainable practices and investing in clean energy. The nuclear industry is an important source of green energy, but nuclear power plants require high-density concrete to shield against toxic radiation. CSIR AMPRI Bhopal has developed a formula to protect the environment from toxic radiation. Dr. Manish Mudgal, a senior scientist at CSIR, developed the Laboratory for Research and Development of Aggregate Concrete Technology.
Conventionally, Department of Atomic Energy is constructing nuclear installation with heavy density concrete by use of hematite ore as coarse and fine aggregate. Let me tell you what is heavy density concrete. So whenever the concrete is having density more than 360 kg per meter cube, it is termed as heavy density concrete. So whenever lead is being used in this particular heavy density concrete, it is toxic in nature and it is carcinogenic also, and it's having very low melting point. So to overcome these drawbacks of heavy density concrete, the CSIR AMPRI has been approached to solve this problem by making use of industrial waste to develop synthetic heavy density aggregate and radiation shielding concrete. So CSIR AMPRI has developed a process for making synthetic aggregate using red mud as source material.
The CSIR AMPRI in Bhopal is working on the bulk utilization of red mud for the development of valuable products like gamma ray shielding concrete.
So after development of red mud based synthetic aggregate, which is heavy density aggregates for radiation shielding purposes, we have to test this aggregate for engineering properties as per IS 2386, impact value, abrasion resistance test and crushing strength has to be evaluated. Impact value, we have to take these developed aggregate in such a form that it has to be passed through 12.5 mm sieve. It should be retained on 10 mm sieve, and these aggregates will be filled in this standard bowl and then in 3 layers, and then 15 rounds of impact will be given so as to get this particular aggregate crushed. This aggregate then again is sieved with different sieves, and the evaluation of impact value will be completed. Now we are doing the Los Angeles abrasion resistance test. So this aggregates will be filled in this particular container, and after that these balls will be kept in this aggregate, giving revolutions, and abrasion resistance value will be calculated. Now we have to do crushing value evaluation. So crushing value evaluation has to be done with filling this around 3 kg of material has to be taken, and this material has to be crushed with the help of compression testing machine. After crushing of these aggregates, we will do the sieve analysis and then we will find the crushing value as per the IS code standards. And it should be less than 30% for wearing surfaces and it should be less than 45% for general concrete purposes.
The radiation shielding concrete was made using synthetic aggregate in the cement matrix. The developed aggregates on the upscaled level with 4.17 specific gravity were tested for engineering properties. The density of developed concrete using these aggregates is 3.4 to 3.6 grams per cc, and developed concrete has about 20% higher mechanical strength than hematite ore-based concrete.
The developed aggregates are suitable for making heavy-density radiation shielding concrete for nuclear power plants, medical diagnostic centers, shielding for food irradiation chambers, and bunkers for the strategic sector. On March 13, 2021, the Center for Advanced Radiation Shielding and Geopolymeric Materials CARS and GM established at CSIR AMPRI Bhopal was inaugurated. This technology will help conserve non-replenishable hematite ore used for conventional radiation shielding concrete. The successful evaluation of the characteristics of gamma-ray shielding concrete at Bhabha Atomic Research Center, Mumbai was also a feather in the CSIR AMPRI's cap.
This concrete is not having any secondary radiation. This concrete will be as it is concrete because we are replacing that aggregate, and that aggregate has already been tested at bark for this sort of secondary radiation. So the application spectrum is wide, and the CSIR AMPRI, this Center for Advanced Radiation Shielding Material, is ready with this particular process for know-how transfer to any industry.
CSIR AMPRI Bhopal believes that as a nation, we can match our quality to international standards. We are confident that we can deliver indigenous technology.
The objective of Jigysa is to extend the classroom learning by focusing on well-planned research laboratory-based learning for school students. Due to pandemic, students could not visit the labs to get value-added research exposure by scientists. The successful launch and abundant interest shown towards CSIR Jigysa resulted in setting up of the virtual labs. CSIR Jigysa Virtual Lab is an extension of CSIR Jigysa program. CSIR AMPRI reached 152 Kendriya Vidyalaya schools of Bhopal, Jabalpur and Raipur regions and 113 Jawahar Navodaya Vidyalaya in Madhya Pradesh, Chhattisgarh and Odisha. It also covered state government and private schools of Madhya Pradesh. Through this program, CSIR AMPRI has facilitated more than 1.25 lakhs students and teachers.